answer the first question here. How much work is required to lift a 15 kilogram box of physics pump items to a height of 1.08 meters above the ground? So actually, this is work against gravity. So work against gravity. Okay. So if you have an object being lifted up, okay, so the applied force there, the minimum applied force there, it should just be equivalent to the Fg, okay? Because you cannot lift an object upon which you're just applying a force that is less than that. So the work done against gravity here is just, again, Fa times d, but Fa is just Fg times d. So mg, the d is the height, so h. So work is equal to the mass of 15 multiplied by 9.8 times 1.08. So work is 159 joules. Okay. So work done against gravity in this case is, or work done in lifting an object is 159 joules. Okay, so second question. It's Diana's turn to take out the Physics 11 mascot. Rosalita, mass of 4.8 kilogram. If Diana drags Rosalita by a string a distance of 76.0 meters with a force of 32 newtons at an angle of 25.0 degrees to the horizontal, how much work is done pulling Rosalita? So if you're gonna somehow look at this particular, if you're gonna draw a diagram out of this question here, that means that the object or the mascot here is being pulled by a force of 32 newtons. Okay, and if you can see, it is at an angle, so that means that yeah, with regards to the horizontal, the force is angled of 25 degrees above the horizontal. So how much work is done if the distance traveled in pulling the object is 76.0 meter? So that means that, yeah, so the endpoint is here. Okay. So the work done, remember, F must be parallel to the displacement, or we can use F cos theta d. So if you can observe, F here is 32, and then cosine of 25 degrees, 25 degrees. It's not degrees Celsius, but degrees, times the distance of 76 meters. So work done in pulling the mascot is 2.20 times 10 to the power of 3 joules in 3 significant digits. Okay, so the whole 32 newtons is not responsible in moving the object 76 meters. So remember that it's only force that is parallel. So F cos. So that means that this would be your F cos theta. So you're just going to use the F cos theta, the F parallel part. F parallel is just F cos theta. Okay. So number three is you're given a force versus distance graph, and you need to get the work done. Again, if you're given the force against distance graph, area is equals to the work. So area under the graph will give you the work done. So that means that I have this. So I can divide this into sections. So let's say this is my, this is my area 1. Okay. So my area 2 is, let's say, going to use this area 2 here. So that's mere area 2. Okay, I'm gonna make this one as my area 3. And then I'm gonna make this as my area 4. Then finally, I will make use as this my area 5 here. Well, you can break down this particular figure in different sets also. Okay. So if I'm gonna start with A1, that's a rectangle. So that would be, well, let's just say that this is 5 here and this is 7. Okay. So area 1 is base. The base is 5 times the height of 6. So area 1 is 30 joules. And then area 2 is just a rectangle again. That's between 5 to 7. So the base is 2. The height is 6. So that gives me 12 joules. Then area 3 is a triangle, so 1/2. The base is 2, so 2 meters. The height is 6 to 10, that would be 4. So that is 4 joules. Then area 4 is again a triangle, so that would be 1/2. The base is 7 to 10, so that's 3. And then the height would be 2, 4, 6, 8. So this is 2, 4, 6, 8. So 8. So that would be 12 joules. And then finally, area 5 is just a rectangle. So that would be base times the height. So the base is 3, the height is 2. So this is 6 joules. So the work is just the sum of A1 plus A2 plus A3 plus A4 plus A5. So that gives me an answer of, that would be 42, 46, 46, 46, 52, 52 plus 12, 64. 64 joules. So the work is 64 joules. Again, you can break down the different figures there, the different compartments, or the different uh, yes, depending on the figure. But you should get around 64 joules also. Okay, for number 4. An 11-kilogram skateboard is rolling along the sidewalk. Force of 30 Newton is applied in the opposite direction to bring it a stop. How much work is done to slow down the skateboard? So if this is the skateboard, so the free body diagram of which would be, you have FG downward, and then the normal force upward. And then if this is moving to the right, so velocity is to the right, so there must be friction that opposes the, no, this is not friction, but the force being applied. So this is your F. Okay. To bring it to a stop. So this is assuming, again, there's no friction. Okay. So how much work is done to slow down the skateboard? So work done by F. So in this case, work done by F. So if I just gonna write down all the given quantities, you have M of 11 kilograms. The capital F is 30 newtons, and then bring it to a stop. So VF, final velocity is 0. The time is 3.9 seconds. And then the question mark is the work. Well, we don't know how much is the initial speed also. The main question is the work. Okay. So for your solution, since it pertains to how much work is done, so this is work done by the force. So it should be F times D. Well, if you can see here, F is given. Okay, that F is given. However, D is not. So actually, D is also known. Okay, so we need to find first D. So solve for D. Okay, so how do we solve for D? Well, if you can see here, we're given some kinematic equations. Okay, some kinematic quantities. So if you can remember, we have here D is equals to VIT plus 1/2 AT squared. Oh, we can solve this if we are given the initial velocity and the acceleration. So if you can remember in our kinematic equation, all of them contains the acceleration, or I think most of them, or yeah, contains the acceleration quantity. So, and remember that we also don't have VI. So I need to solve for A also, solve for the acceleration. So how would I solve for the acceleration? Well, the net force in this particular case is given by F, okay? And that is given by, yeah. So we can use the second Newton's law that F net is equal to MA, or A is just F net over M. But what is that F net equal to? The F net is just equivalent to this one here, because Fn and Fg just cancels out. So F net is given by F. So let us say that going to the right is my positive direction. So A would be, F net would be negative 30 over, this would be mass of 11. So this is around negative 2.73 meters per second squared. So therefore, acceleration is negative 2.73 meters per second. But aside from A, I need to solve for VI. Well, how would you solve for VI? So I need to solve for VI. Solve for VI. Well, I'm given now the value of VF, which is 0. The time is given as 3.9 seconds. And from the computation that we have, A is negative 2.73 meters per second. Well, we have three equations given, or three quantities given. So that means that we can use either of the displacement equations to solve for that VI. So looking at your set of equations, you can find an equation that looks like this. So we're in VI is just equal to VF minus AT. So final velocity is 0 minus A is negative 2.73 times the time of 3.9. So VI is positive 10.6 meters per second. So positive, so meaning initially this particular skateboard is moving to the right. So indeed, it's true. Well, at least our computation is consistent with our diagram. So now we have VI. So we can solve for D. Just have to substitute our VI. So that's 10. So this VI here is coming from here. Okay, so 10.6 times the time of 3.9 plus 1/2 of negative 2.73 multiplied by the time of 3.9 squared. So D would be around 20.7 meters. Okay, so D therefore is 20.7 meters. So now we can substitute this one to the value of D in our work equation. So work is 30 times 20.7. So work is equal to 622 joules. So this is the work done in trying to stop the object or stop the skateboard. So number 5, calculate the kinetic energy of a 1,250 kilogram car that is traveling at a speed of 40 kilometers per hour. So I'm just gonna write my given first. So given is mass of 1250 kilograms, and then V of 40.0 kilometers per hour. And then I need to compute for the kinetic energy. Well, if you can see here, my speed is in kilometers per hour. So I need to convert this one to meters per second. So if I'm going to convert that one, that would be 1 hour, 3,600 seconds multiplied by, well, 10 to the power of 3 meters for every kilometer. So that gives me around 11.11 meters per second. So now for my solution. So you're solving for the kinetic energy. So that would be 1/2 mv squared. So 1/2 of the mass is 1250 times 11.1 squared. Excuse me. So this gives me 7.72 times 10 to the power of 4 joules. So kinetic energy would be equivalent to that. Okay. Okay, number 6. How much potential energy is there in a 27 kilogram boulder that rests on a 15-meter cliff? At what speed would the boulder strike the ground when it failed the height? So potential energy. So let's start first with the given. The mass is 27 kilograms. Height is 15 meters. And then, well, just use the G of 9.8. So in the first question, we want to get the potential energy and as well as what would be the speed at the bottom when if it falls down the cliff. So solution. So potential energy equation is given by mgh. So just plug and compute. So 27 times 9.8 times the height of 15. So potential energy is equal to in 3 sig figs. Okay, the givens are in 3 sig figs, so the answer is in 3 sig figs. So that would be the answer of the potential energy. But it should strike the ground. In striking the ground, that would